So it's time, and you guys can all actually hear me properly? I believe so. I'm loud enough. So this, I didn't want to get into a discussion where I'm trying to show some slides because this is supposed to be design discussion. It's about OpenFlow clustering and what you're going to achieve with that, and actually what are the goals and what we are trying to do in this beryllium time frame. So we have 3 or 4 people who can speak with us. We have Moiz, we have Anil, Vishnoi, we have Pantelis, and we have some other folks also from the OpenFlow plugin. Oh, you can hear me now? Okay. So let me start with the initial set of slides which I want to show. Where do this from start? Okay. So what's the goal we are trying to achieve here? We are trying to achieve HA, and the idea which we are coming up with is like there's going to be one master for each device, which is going to be responsible and own the device and write the flows as well as configure the device, and the rest of the controllers within the cluster will behave as slaves for the device. That's what the OpenFlow protocol is like. One can be the master, like a master and slave role relationship. By default, it's having an equal relationship, but we can go with a master-slave relationship for having HA. Second is scale. So we are trying to achieve horizontal scaling such that if more devices gets added, we can add more controllers, sort of scale horizontally. And also in this time frame, we are trying to service some apps which can be made cluster aware. And there's some discussion going on around that, what we need from the API front for these apps to be cluster aware. And in this beryllium, we are trying to make how we can make changes to statistics and try to make it better. And based on existing frameworks, what we can do so that we don't have a huge time lag from the start we design, so that we can complete this in this time frame. So that because this OpenFlow clustering is in great demand that people need to scale and achieve. So roughly, this is what the initial, when we didn't have OpenFlow clustering, this is what some people did to achieve HA at least. So, but there's no scale over here, where you have like a set of switches over here, and there's a bunch of controllers, and so you can have a virtual IP or a VIP or a VIP to which you connect to another controllers, and if suppose C1 dies, then the VIP moves to C2, and that's the way you can achieve HA. This was the initial set when we didn't have OpenFlow clustering, and some people achieved HA by this. But there's no scale over here. Like for example, all the switches are being serviced by just one controller at a time. C2 and C3 are practically slaves for this set of switches. Another OpenFlow based solution which has been tried was that these set of switches are connected to all the controllers like a mesh. And using OpenFlow, we configure the switches saying that one of them is the master and the rest are slaves. So in this scenario, I'm saying that C1 is the master for S1, S2, S3. How that is done, that should, it can be done in the form that we can try to follow the leadership of a shard of a data store, inventory config or inventory operational, and try to follow that shard and try to make that node as the master wherever that data store shard is the leader. Again, this is just HA and no scale as such over here. So what we are trying to achieve here is that we need to have some scale and HA solution. And the way we can achieve it is that if we can distribute the ownership of this switches across these controllers, and So what are the assumptions which this design has, and which are subject to discussions over here, that what we are trying to come up with, is that we would not be piggybacking on the data store granular sharding. This design can be completely abstracted from the data store sharding, and how the data store is sharded. That is one of the assumptions which I'm making in this design, and it's going to be a symmetrical system. All apps are present in all the cluster members. So this is a design write-up. This was a presentation I had done at the OpenFlow plugin meets and all this, so that's why we had this design, but I won't go with that. So roughly, I'm going to go with the slides, and so that we can understand design, and then we can discuss more on the whiteboard, because this is a design discussion. This is not going to be a presentation. This is one such topology which I'm trying to present, so that we can go over multiple scenarios over here. So we have the OpenFlow plugin, and we have two switches. These switches do a handshake with two of the controllers, and that is something called a clustering service, which will determine some service, some clustering service and ownership service, which will determine that which of these controllers can get an ownership for a particular device. Now, the word ownership is also subject to discussion, like what should we call it? And the concept is that each of this handshake which happens comes with some kind of entities, which in then will try to request an ownership from the clustering service. And we can call it as registering that entity with the service, and then it tries to request a lock. So don't get bothered by the part of the lock leader, because this is completely abstracted from, it is going to be completely abstracted from the OpenFlow plugin clustering project. It's going to be part of the controller project, where we are going to give this service not just for OpenFlow plugin, but possibly for some other apps which want to become cluster aware as well. And so it's going to request a lock, and it's going to get some, and this is the way it's going to be, in the sense that the member 2 for OF1 has got one master over there, and they get selected. The way it gets selected can be also based on the strategy which can be plugged in by the app. In case of OpenFlow plugin, it can be like a first come, first serve. Like if the clustering service or the ownership service gets the request from multiple entities saying that I need to get an ownership, then based on the first come, first serve basis, it can try to decide, or it can be a load shared strategy. So based on a different strategy, it can try to acquire the ownership for a particular device. And then it can, then there are some apps which like Stats Manager and all the stuff which can be notified that, I am the master for this device. And based on that, these apps can also try to make decisions as to what they have to do on a particular node. This is with the assumption that it's a symmetrical system where all the apps are present in all the members. So this is one of the HA scenarios which I'm trying to just present here. Like if suppose one of the virtual members die, and then how the other one takes up. Like for example, here the clustering service leader dies, and then this gets notified to all the different entities which don't own them, and they all request ownership. Since 2 is already being owned by member 3, 2 will be denied the ownership. And this is something with a different scenario where like a follower dies, like in the sense that the master of OF1 has died. The member where who owned OF1 and who was responsible to write and read has died. So all the So in member 1, you can see that the entity which didn't own will get a notification saying that that member has gone down. This is achieved through ACA because the lock actor, which we see the 3 boxes at the top, they are actually actors of ACA, and when an ACA member goes down, we get a cluster down event through which we know that something has gone down, and with that event we try to do this. So this guy requests an ownership, and that way that person becomes owner. So this is a set of slides which I'm trying to just present as to how things will work. Here I'm trying to convey the multiple hops which might happen between the 3 nodes. So this is a flow mod which has been initiated from a node where the inventory config is later. This design assumes that there is no granular sharding at this moment in the data store. It's pretty much so we have an inventory config master at the it's in the first node, and the inventory operational in the 3rd node. We have a remote RPC connector, which is all the 3 nodes. Through our election mechanism, the member 2 has become the master for the switch. Now I'm trying to make a flow mod from the member 1. So the way it will work is that the flow mod will first be the flow mod will result in insertion into the inventory config data store master, and from that the forwarding rules manager will get a notification. It will pick it up. It will try to make a flow mod. It will call an RPC. Now wherever the master is, we register the RPCs for the switch only in that node. We deregister the RPCs which are on the slave nodes. So the remote RPC connector knows that the RPC for the flow mod for this switch is present in the node 2, like the controller 2. So that request will get routed to the node 2, and which will then make a flow mod to the switch. And this is another scenario where you're trying to make it's pretty much the same thing, but you're trying to make a flow mod on a node where the inventory config is the follower, and that's where you see there's one more hop. It goes to the inventory config shard follower, and from there it goes to the master gets it, same FRM, picks it up, makes an RPC, and then it goes to the master. So this is the number of hops which will be there around the cluster to make a flow mod with this design. And statistics, irrespective of whether we are using the lithium design of OpenFlow plugin or the helium design of OpenFlow plugin, statistics manager tries to put the stats collected into the operational store. So what will happen? But in the lithium design, we have the privilege to know that since it is ingrained within the plugin itself, we have the privilege to know that this plugin is acting in the master node or the slave node for a particular switch. So we can have some knobs in the stats manager to control it better. In the helium design, the stats manager is situated outside of the OpenFlow plugin as an app. So what's happening over here is that the stats manager makes a request, makes an RPC, and that RPC is going to the switch. You get a notification back from the switch saying that, like a multi-part response back, which is picked up by the stats manager from the switch. That's the 3. That's the number 3 over there. And the stats manager that tries to store it into the inventory operational, which is local, and the inventory operational is follower in that node. So then all the stats will get put to the master, which is in some other node. So this is how the stats manager will work if the master of that particular OF node doesn't have an inventory operational leader. that's in rough the design, and this part of the slide is much more detailed about the code and what changes we have to make in OpenFlow plugin. But I believe that this is the point where it will stop and see if we can drill down and see what we can do better, or if somebody have any questions related to that. Or we're going to discuss, or we can take this discussion to the whiteboards and then talk about it.
So every flow mod would have to go to the master?
I'm sorry?
Every flow mod would be routed through the train master?
So flow mods can be made in two ways. One is using the SalFlow service, direct RPC, and the second way is to insert into the config data store. So, but the config data store, anything you insert in the follower of the data store gets routed to the leader. Is that what your question was?
Yeah, so then the idea basically would be that you just would not want to use the MSAL version of that, right? Because you won't get scale if everything has to go to one node, right?
No, it's the data which is getting stored.
The data is which getting
You
stored.
have to send the data to the master so that it gets, basically you're using a consistent store, that's why.
Data to the leader. So let's put the terms master for OpenFlow and the leader for data store so that they don't. Okay, so the leader of the data store, we need to take it to the leader of the data store, which is a fully consistent data store. So one person first commits it, and then the followers commit, like that way.
Is there a way to write flows that if I'm running an application that's on the master of a given switch, and I just want to compute the flow mods for that switch on that particular controller node, would I be able to just directly write flow mods down to that switch that are computed locally?
I believe we have a SalFlow service where you can have an add flow RPC directly, but the drawback to that is that the config data store is a persistent data store. So if you make a flow mod and tomorrow your controller goes down, you won't be able to recover all the flows which you installed in the switch. But and
I can recompute them from the same policy that I used to.
yeah, you can do that. You can do that.
If you can recompute them, then that's not a problem.
Yeah, that's no problem.
Yeah, then it's okay.
Yeah, then it's okay.
The only use case where you would want to have them be persistent is where the user is specifically giving you, I want this exact flow mod installed. If I have an application that's computing a set of flow mods from a set of policies, then
you can use
I
the
always just
SalFlow.
want to compute them locally to the master switch and then write them down to that master
Yeah.
switch. I don't want to write flow mods from another controller. Because then I'm just magnifying the amount of data that I need to replicate.
Actually, that's why his examples, he was showing the flow mod being done, like the flow was being added from the mod bar. So user is essentially configuring the flow.
Okay, so
But
if
if
that,
you- if
is
you
that,
have
that's not the primary use case,
So
right?
which is fine. If you
Yeah.
have group-based policy, we're always computing the flows. You can just call the add flow RPC, which is okay. That
Mike.
you can do. If you can always compute the flows.
But is there, the question is there an
So do we have a mic for this so that so others can hear as well?
There is an API,
No, no.
add flow RPC is there.
But,
That's not the-
but with the management of the masters and the slaves and being able to tell which node is the master computing switch, how do you know, et cetera,
One
et
is
cetera?
once you call this add flow, then let's say you are calling on a calling on an instance where the switch, whatever is connected, that's basically connected as a slave. So you need to send it to the master so that that master instance can actually write it on the switch, because that's the master that you are slave. So that routing is something that how that will happen. I think that will happen.
Yeah,
if
there's
you
no
guys-
reason to compute it anywhere but the node that is the master for that switch.
Okay, so is your question that if I had a switch for which the master was on node 2 and you're calling the add flow RPC from node 1, that's
Yeah.
the problem for you. So you want to actually co-locate your application on node 2 so that it's a local call. Is that what you want to do?
Yeah, exactly.
And I think that we can do. So this the leadership service that we're talking about,
Yeah.
they'll have a way to find out which is the master. Yeah.
Yeah. So that was the initial thing, but it was like the goals which we were trying to say. I was trying to come with the goals. I believe somewhere over there. That the service to support cluster our apps. Like you should be knowing where you want to reside, and if we can provide that kind of service, then your app can reside to a place where you want to co-locate with a particular shard or co-locate with, then you can do that. we'll be generating notifications based on the shard leadership so that you can co-locate if that's what you want. And then you can try to do the logic.
Well, it's not, I don't know if the shard corresponds exactly to the master of particular, like the OpenFlow master.
We'll have, I think, it doesn't have to be shard leadership. It can be the lead, basically like a switch gain mastership on one.
Okay, master node. Okay, yeah.
We can
Yeah,
actually
we can do that. Yeah.
where that master is and give a notification to somebody who subscribed to that. Says, okay, tell me where is the open
Right, like the stats manager is getting that. See, the stats manager is getting a notification saying that you are residing on a master node. So now you can do what you want to do with it. So your app can do something very similar to that, right? Does that make sense? I'm not sure.
Maybe. Yeah, it's a lot of extra machinery to accomplish something that's actually ultimately pretty simple.
Okay.
But maybe it lets you also do the simple thing.
It's a thin line between flexibility, like you have to be flexible enough to accommodate more apps, plus you have to have clustering also involved. So this is some,
Well, I mean, any app that's having to compute a significant number of flows on nodes where it isn't the master, where you're having to like write flows all over the place and it's synchronizing, you're not going to get scale, right? I mean, it's going to be extremely slow.
but the thing is,
Well, my point is, why would you want to ever have an app that doesn't need co-location?
why you don't want to app for not to co-locate with the master?
Assuming that you're talking OpenFlow. I mean, maybe
Yes.
you have some other thing that
Okay,
This is not OpenFlow specific.
there's no,
yeah.
yeah, this,
I know this is a total pain, but if
Yeah.
there's any session where people are going to want to watch this later, it will probably be the track that's going on in here.
Nobody cares what I want. What I
Yes, they do, yes, they do. So I got a handheld mic, please try to do your best.
Is this on?
Both for everybody.
well, I believe, so there will be a switch, there will be a switch over there probably.
It says it's on, but I don't think it's being amplified, just recorded, right?
What's that?
Is it being amplified?
Check.
Yeah, we have to just close it.
Hello? Oh, okay.
Okay, thanks guys, sorry, didn't mean to interrupt.
Sure.
Okay. I didn't actually have anything else to say.
Okay. Okay. Okay, so,
So your point is that if it's an OpenFlow application, it has to be co-located with the switch. Is that your point?
Yes.
Okay.
just,
I mean, and honestly, for any app that you have this kind of model where there's going to be a master for a given device.
No, but how you decide that, co-location part of it, because devices are connected to different instances of it, right? So let's say there are 3 switches and all 3 instances are kind of master for those 3 devices, right?
yes.
Basically, it says that, all your instances are going to be sitting in a master for that switch at least, right?
So I want to compute the set of flows for a given switch on the controller that is a master for that switch. So I might have a given controller that's mastered 5,000 switches, and I want to compute the flows for those 5,000. I have another controller that's a master for another 5,000, and I want to compute the flows for those 5,000 switches on that computer.
Yeah, so that's where the problem is, right? If master is there, you can directly call the RPC and things will go directly to add, because I'm not sure whether the RPC routing will be happen based on the mastership of OpenFlow on a device, or
It's going to
shard-
happen,
based on sharding. I know that
No,
you do all
so the
that.
mastership and the RPC registration will be happening based on the actual device context.
Yeah, so my point is, if there is device 1, there is device 2,
Yes.
and you are sitting in device 1, right?
See,
And
The main
somebody wants to
assumption was that
program a
it's a
flow on device 2, that's not going to happen, right?
this is going to be a symmetrical system where the app instance will locate in each and every node.
Yeah.
And so based on notifications of the master, the app can work on that device, and your instance on the M3 will work on the device 2. So you will get notifications and you can work with the device.
So yeah, point is, application is going to be, master where your devices are connected. If 10 switches are connected to one instance, that application instance is going to be master of that, those 10 switches. So you can program those switches directly. There is no complexity. So this co-location is distributed, but
You can program them in such a way
Yes.
Because you're going to follow RPCs.
Yep.
RPCs. Yeah.
So, Kamal, is it possible to have an option where for a situation like his thing, in order to simplify the application development, I want all of the master for all of the switches on one of the nodes.
Master of all of the switches on that is based on the strategy which you put in.
Yes.
So the strategy can be plugged in, saying that I want all the switches to, like, all the mastership to be having this one node. So based on a strategy, that node will always be
Yeah.
actually winning the election.
Yeah.
So we are trying to keep it fairly flexible so that we understand that there are multiple scenarios which people might implement. Oh, I don't want this way, I want that way. So based on the strategy, we can try to do something like that. That's the goal. That's the
I think we need to get into the specifics.
yes.
Yeah.
We've been talking with like really high level.
Yeah.
Yeah.
Start drilling.
Yeah, drilling down and trying to see.
I mean, one property of this is computing these things is actually not very expensive. So, like, if you've designed it and built it correctly, you can actually support a really surprisingly large number of switches on just a single controller instance. You know, if you a single controller instance, you should easily be able to do millions of flow lines per second. And you need to be at a very large scale on your network before you get past the capacity of a single controller instance. And you know, I don't know that anyone is contemplating building networks at the moment with OpenDaylight with so many switches that you actually would exceed the capacity of what should be possible on a single node. I don't know what's actually possible currently.
What if the controllers are very far, or the switches are very far apart from each other?
Yeah, then you start having to think about federation models. You know, I think I'd actually be curious how the store handles right now with very high latency connections between. You know, if you're talking about you no longer have millisecond latency, you have 500 millisecond latency or 100 millisecond latency.
We've tried that.
Uh,
I mean, of course, they throw across. No. If there is high latency between the controller instances, of course, it's going to impact them. It's going to impact it pretty badly because
Yeah.
every transaction has to go through the leader, then get replicated to at least a majority of its followers.
yeah.
So I guess if you want to program a lot of flows, maybe programming it by actually configuring it first into the data store and then doing the add flow maybe not the right way, as you said. Computing it is the best way. But that should be okay, I think, as long as you keep it local. Because if you have to go across again, you'll have the same latency problem, right?
Yeah.
For going across, you have to use the data store, right?
No, you don't have to. So when you invoke the RPC from node 1 for a switch which is on node 2, because the switch is only on node 2, you actually register the add flow RPC, right? For that particular switch.
Also, there is
Exactly.
So the
So the RPC, remote RPC connector takes care of that. You don't have to go through the data store.
yeah, but that is because we are distributing switches anywhere, right? So
Yeah.
some of these need to be happening, right? It's-
Exactly, but again,
can't really make it
no, I'm just saying if you're, yeah.
Is there a way to guarantee that the flow programmer RPC would always be local? Like if the leadership changes while I've got stuff in flight.
Or something that returns that index, so this would be routed to something so that you know it is right?
Well, like say I'm happily programming a bunch of flows and I lose my leadership, but I've still got some asynchronous thing that's going that's programming flows. Now is it going to end up saying, oh, now the leadership's over there. Let me send all this stuff across the network to this other guy and finish those RPCs off on the new leader.
Talking about your switches leadership changes?
Yeah.
Masters only.
Or
masters.
well, either way, frankly, is there a chance where I could have some asynchronous thing where, the
It'll be best if look at that. So we'll have to examine that case. I mean, first of all, create a test case like that, and then see what happens. I don't think
Especially if
it's
it-
very well right now.
yeah.
Right now, what we're afraid of is the geographical distribution of clusters. Acronyms don't seem to be very good for. So keeping the controllers
Yeah.
all in the same locality,
Yeah, assuming you're doing kind of a proactive flow setup model, I think by far the preferred approach would be to distribute the policy that's necessary in order to program the switches, and then program the switches locally. Honestly, as far as programming switches, I don't think you need anything more than just an OpenFlow API for the local set of switches. You don't need MDSAL, you don't need RPCs, you just need an API for programming the set of switches that are local. Because there is the use case of wanting to program, like I have a set of static flows that I want to just configure. That that's useful for like prototyping and stuff, but it's not kind of the primary way that you would ever want to write an OpenFlow app.
Why do you say you wouldn't need MDSAL? Because MDSAL actually provides you location transparency.
Well, but you don't want location transparency for programming
But if
flows.
it's local, we actually
MDSAL is great for distributing the policy that I talked about. That needs to be distributed. But writing the flow rules, I don't think you're gaining anything by going through MDSAL for the OpenFlow plugin.
all it's doing is, if it's local, if your provider is local, it's
Uh-huh.
not going to go over the network. It's just going to call the RPC.
But why do you need all that machinery? What's it doing?
In case it's somewhere else.
I've got this elaborate machinery for making a function call.
Yeah, but if it's
A local function call.
if it's
No, but I want it to always be local. That's the point that I'm making, is that if I'm writing a real OpenFlow app,
But I think that's in the application context. If you're
Yeah.
writing an application, you can write your application in that way to do that. That's just something you can do, right? But that's one of the things.
yeah.
Okay, I
Now
want
you could
to
write
local.
an application on top of this that would be the OpenFlow static flow setup, MDSAL application. But the actual apps that are responsible for, I think, the real apps that might want to use OpenFlow are not going to want to go through MDSAL, especially a persistent replicated MDSAL, in order to program individual flows. I don't think any real app
When
would
you
do
say
that.
MDSAL, you're really talking about the data storage part of it.
Yeah, well, but any part of it. I mean, if I just designed, if I just have a simple Java API for programming OpenFlow flows, I don't need an RPC because
So no RPC is
I would
true,
actually want a guarantee to ensure that my RPC is actually fully local.
I think the confusing part is it's called RPC,
Yeah.
but it's not really remote.
Well, but it could be remote.
doesn't have
It's an API that's designed to allow remote, to allow an actual remote call in a location transparent way. But in this case of OpenFlow, which is one of the primary use cases of an OpenFlow controller, of course, like I actually want to go further and say that I want to guarantee that my RPC is always local. I want to ensure that it could not ever go over the network.
Maybe the advantage of going through.
And there's a great way of doing
MDSAL
that, and it's called a
is that
function
you have
call.
a common API, that's used by
Uh-huh.
everybody. You don't have to learn all these. That's ADSAL, right? Where you wrote Java APIs for everything.
Uh-huh.
Different Java APIs for, custom Java APIs.
Well, and
So that maybe that's. I think we're getting off
Uh-huh.
topic.
Yeah.
So before we go.
yeah, this is going beyond the cluster.
Did you also
Can
look
you?
at the possibility of choosing like a
Use this.
probably, instead of master-slave model, probably equal kind of model where, I think that maybe is closer to even for OVSDB, right? If you consider OVSDB kind of scenario, where the server is actually in the virtual switch itself, right? So what happens if you have the OpenFlow switches sort of follow the similar model where it is equal, anybody can write, just like the OVSDB, anybody can be a client, and so then in that scenario, all you would have is that between node 1 and node 2, who has the equal opportunity to write it to that same switch, then all you just need to do is that just lock the flow before you actually modify, so that the other guy wouldn't just modify the flow at the same time you need to modify.
You want to take that? Like OpenDB, I'm not sure how it's going to work.
So this is general problem where you're saying that everybody can kind of program the device, right? It's now the decision is we are leaving to the application. Okay, so now application need to decide that all the application can access all the switches. That is the first requirement will be there, that you have to connect all the switches to all the instances of this thing, right?
which you could do even in equal.
Yeah, so equal mode is a switch mode, where equal mode is anybody can write on this one. Right? A master, in case of master slave, master can write. Whoever is the master can write, slave can't write. Equal mode, anybody can write. Right? This is what you're saying. So then this ownership case is not going to be there. Right, you don't really need a ownership kind of thing. You are saying, okay, application will do it. Now the application has to decide, who who is going to write onto, because there are 3 instances running in the same way. And if somebody install a flow to config data store and you want to install it, everybody will get notified. Now the problem is application need to decide who should take that flow and install it on the switch, right? Because otherwise these 3 will act in the same way. They get a notification, they'll say, okay, flow need to be installed, and all 3 will try to install on a switch. Okay, and one of them will succeed.
Yeah, that notification will be given. But the problem with the equal role is that all the messages from the switch will be appearing to all the 3 controllers, and all the applications have to be knowledgeable enough to sort of dissect and find out, okay, if I'm not the master, then I should not be taking care of this and all that stuff. See, one thing is that if we don't do any of this, by default the role is equal. So as of now, if you take the controller of Lithium and connect your switches, by default it's equal. It's equal. You don't have to do anything.
It's a fascinatingly useless mode. Like, you can't use that, right?
Yeah, and that's the tricky part here.
Yeah,
that's the tricky part. That's what we are trying to solve with this. We try.
All I'm trying to say is that there is an OpenFlow side of establishing master and slave, and then there is another side which is the clustering side of establishing who is the leader and who is the follower. So either you basically bring them all close together, where the kind of model we try to do in the 2-node strategy, which is master is exactly is always the one guy who is sending everybody. That's one possibility. The other possibility is that if you just equalize on one side, then all you need to ensure in the data store is just a locking mechanism, somehow that whoever is modifying that entity is somehow locked. I mean, that's one other possibility.
Yeah, I think there's the same sharding issues, right? Where if
Session level load balancing, this master and slave is essentially you're doing load balancing at a session level. You're choosing who is the master for this session until it builds over. Whereas if you did equal, you're doing flow level or message level load balancing. Each message could go from any one of the nodes. I think we can think of that as a more advanced mode. It puts more responsibility on the applications to be able to coordinate that. This one is a little easier on the applications because system is taking care of that. We can see that as an advanced mode. If necessary, it can be made available. But this is really what we need first. Is this
Yeah.
Well, another possibility, continuing to build up on that, while you're writing the OF flows from the controller to the switch, maybe any of the nodes can write to the switch. You can do it using the distributed route or whatever the MDs have been going. But it is a reverse direction from switch to the controller. Maybe we can nominate who can be the master for the reverse communication from the switch to one of the node as the master.
Okay, so you're saying that anybody can write to the switch, but just one of them will receive the actual notification from the switch.
Exactly. So it makes it a little bit simpler.
That you can do in the same way by setting the sync message to be sent to a particular controller only.
We need to find a use cases for, see, there are many different possibilities we can do, but we need to find some use cases. Do we really need this, or we are just actually making this like, okay, actually we can do this, we can do a lot of things, but the thing is that we have to come with a simplest design which people can use in most of the scenarios. 85% scenarios people can use it, then it's a success. That's what I believe in.
I mean, I think that's actually something, he's making, I think, something that's a very deep point in that we're trying to build we're trying to build something that's actually going to be useful. We're not trying to imagine the ultimate clustering solution that can solve every clustering problem ever.
Right.
So I think we definitely need to be very focused on ensuring that the design of everything we do in ODL is driven by what we actually want to build as far as real use cases and not what we imagine could be possible. I think we do we do already a little too much of over designing on things like this.
Done. We're good to go.
Use case is fine, right? Use case is fine, but eventually when it comes to the plugin, right? Plugin has some responsibilities to do, right? We need to decide on this, right? My point is the use cases are always going to consume it, okay? And that's going to be transparent for them, right? Now the point is how you want to internally manage it, so it's kind of give you a scalability. That's the concern. That's why, when we initially started, we said, just like folks said, why not make applications sit in a place where you are the owner of a shard, you are owner of device as well. So everything on the same place, right?
That's
But-
the place, yeah.
Yeah, so this is a simpler solution. But the point is, what if your application is dependent on two shards? Okay, then there is multiple application can happen, and this is going to create a mess. And these guys are not going to do that because that's not a scalable model for them, right? Because you are writing an application, but you can't really screw up the platform, right? So that's where we went ahead and try to distribute these switches. Let's see all the instances to work it. Okay, all the instances will be active instances. There is no standby mode. Okay, in the first model, these two instances, controller 2 and controller 3 is going to be in a standby mode. If we connect all the switches to one and everything master and everything is there, right? So that's an active standby mode, and those two controllers is not going to do anything. Here we are distributing the, functionality among all these three instances. So everybody will act on set of devices, right? Your idea was, if we can locally do for those devices which we own, that's where the application come into picture, and they need to write in a way that's going to, boost the scalability even more, right? But that's where the use cases come, that how you want to build that application, I believe.
Well, I think that's actually something slightly more fundamental. If you're computing, I don't know, maybe there's some application in the world where you would want to run in an equal mode, and like one controller writes one flow table and another controller writes another flow table. I'm having difficulty imagining that application, but maybe it exists. I don't know. But I think the job of the layer above, the data store, is fundamentally to get the data that's necessary in order to compute those flows to the right node, whether it's one shard or multiple shards. That's the job of the data store. The actual writing of the OpenFlow part is actually the easy part. The replication of the policy is but we have to be careful not to make the easy part into a hard problem.
Right.
So one thing is that from an app perspective, they need to qualify themselves. Are they going to be cluster aware or they're not cluster aware? For instance, you got the producer app and you got the consumer app. Definitely in the case of producer app, at the time of deployment or when it is becoming activated, it needs to define itself. This is going to support cluster. That means multiple instances of this producer app are sitting in all the nodes, and among them they can decide how they want to do the leverage the clustering capability, right? Master one side and reverse the
Right.
other side.
Right.
Is there really a lot of call for apps that are not cluster aware?
If they are not cluster aware, then they are bound to sticky session or we switch to the particular.
But why would we want to have apps that are not cluster aware?
No, currently we have apps which are not cluster aware.
But why?
I'm not saying that that should be the case, but there are apps which are not cluster
I
aware.
mean, the reason we have that is because we didn't have the clustering until after the apps were
Yes,
written.
yes,
But
because
now,
that was taught.
now we're in this position. But
Yes.
frankly, apps that are not cluster aware, like they're not useful. They're toys.
Yeah, I know, but the thing is that we need to be sort of backward compatible and sort of support them as well.
I don't think we do.
Fixing this looking.
I think they can run on an old version of the controller until they support clustering.
No, but this
Well-
hardware design for the clustering that says, okay, think of clustering as an intra-piece in your controller. Apps need not need to be, okay, whether it's a 2-node, 3-node, 10-node cluster, apps should work as is. That's a design philosophy when you're working with cluster applications on top of some
Well, I mean,
Okay, finish.
I mean, I think that's a good.
Application to do that, but if you want performance and scale and everything, then you may need to bring in some cluster awareness into your application. So you cannot say that
Who doesn't want performance and scale? Raise your hands.
someone writing application for the first time may not be aware of it. So it might be a learning two-step process kind of thing.
Well, I mean, I think fundamentally the idea that you can design your APIs.
Then comes performance and scale. So you
I mean-
will not get someone who goes through all the single possibilities.
The problem is that you're going to try to design your APIs in a way that tries to hide the fact that clustering exists, and I don't think you can do that. I think clustering is something that permeates the fabric of an
It's
application.
actually been done. So I was the carrier grade architect at Nortel for a number of years, and we had 40 million lines of application code. None of them knew anything except they were running on a single processor.
Yeah.
We had 1 million lines of code at the bottom that was done by very clever people, like the people in this room, who knew about synchronization and clustering and all that sort of stuff, and it was all hidden, right? It was always an active model. We had 16 processors running in parallel, and we logged actions and synchronized them across it, and every application thought they were running on a single processor.
So how did resiliency work? So let's say you have an application on one node here,
Yep.
and that node goes away.
Yeah,
And if you
so,
have a mirror
so
copy of
it's
that,
active, so each application thinks it's running in one thing. It's actually updating good data stored in multiple places. And its state, its actual process state, is on both places. So if it dies here, it looks just like a task swap, and all of a sudden it's running on this processor.
so it's left to the infrastructure to synchronize.
Pardon me?
It's left to the underlying infrastructure.
Yeah, and you need specially clever people to do that really hard stuff. I guarantee you, most application designers don't know how to do it.
Exactly.
Right, and you're going to make a very brittle system if you have this master-slave information going across all the applications. And you're going to get these race conditions where you're halfway through doing something and you suddenly aren't active anymore. You
So-
need a base layer that hides all
What
that.
what is the consistency model of that system?
Pardon me?
You're doing like full memory state synchronization or
Yes.
something?
Yes.
Okay, and what's the scalability of that? I mean,
We got up to.
Up to 16?
16 processors, up to the equivalent of 16.
running on one box?
What's that?
Running on one box?
Running on one shelf.
Okay, but how about distributed
16 blades.
geographically?
16 blades.
Distributed geographically?
We had that as well, but that was a different layer. Again,
Okay.
a different set of really clever people who synchronized that exact same state across a continent.
So what does it mean is that there are cases where you have legacy applications that you want to run on the OpenFlow. You are not HA aware.
Well,
Right.
what I'm saying is I haven't heard the vision idea yet. What's the goal? What are you trying to achieve, right? So when you design something, you have to say, what are my axioms of what I want to do? And one of your axioms, I claim, is you want to say 99% of your applications have no clue that there's any redundancy whatsoever.
So the goals were to provide HA and scale.
But those are given. What's the next goal?
The next goal is to
From
provide,
the application perspective.
so from the application's perspective, provide them that much service and that many APIs so that they can be cluster aware.
That's what I'm saying. That's a mistake. It's going to be brittle.
Okay.
And you're all going to. It's going to take.
But that suggests what we should do.
Pardon me?
That suggests what we should do.
I think I just did.
So
Actually, I said your application, an axiom should be that most of your applications have no clue about it because they're not qualified to even know about it. Right?
So what you're saying is we should not have this mastership. What
No,
we're just talking
I
about.
have no problem with the internals of what that million lines of really smart code does, but from the application's perspective, it's like, I'm a single processor and I'm an idiot, I'm just gonna go for it, right? And if you wanna hide, internally, if you wanna have a mastership, a master-slave thing, and you synchronize the state so that it's hidden from them, and maybe that takes a while, in some places it takes a while to synchronize that state to where it was, cool. You use logging and things, so you keep that state, you're able to get it to a consistent state. The cool thing is you don't even need to guarantee you don't lose anything. All you have to guarantee is when the application wakes up from his task switch, he has a consistent state.
I believe the current design is to allow cluster unaware applications so that suddenly when you appear to say you know machine is not working, it will continue to work. But we would optimize for cluster aware applications because I do believe a cluster aware application which is knows how to do it better can be a lot more efficient than a system giving it automatically
applications aren't cluster aware, that forces those really smart people in this room to become a very efficient synchronization model. And it can be done. We have
See,
40 million people doing this.
well, okay, so we are talking about very simple, we are talking,
Do you want to just come up here and draw on one of these easels how the APIs work and how those applications work, and we can propose that and talk about it.
All the system where the application are clustered away, they all are screwed up. Now my point is, whatever example you are giving, that's a good example, and you achieve a lot of performance and scalability and all those things. Where you are saying application are not clustered away. My point is, if application are clustered away and all those systems are not giving up any scalability of performance or not, my point is, if those systems also can give us the same kind of performance, I think we should not talk on performance. Now it's about the usability perspective, that how much pain you want to give to the applications, right? Because to make the application cluster away, there is a pain. My point is, but you can achieve more performance out of it, then I think it's a trade-off. Okay? And it need to be looked at from that perspective, right? If the point is, if internally we take a decision that whoever wants to be cluster aware, they need whoever want to run their application in a clustering mode, they need to be cluster aware. Then the second option goes out of it.
That's my point. Your axiom is that cluster awareness improves performance, right? My axiom is it doesn't. It's like a guy, in the old days we used to say, if you don't do it in assembly, you can't do it fast. You know what, you can do fast in Java, right? You just have to do good Java engine.
Are you trying to propose that there is no trade-off?
I'm trying to propose that quality, there is no trade-off.
I don't-
If you do it right, the bottom layer does this so well, everybody just wins.
see, when you say the bottom layer, that's where the magic all happens, I believe, but you're not giving actually more insights into it, because that's where the complexity lies.
Yeah, that's actually what we're asking. Can you just tell us what is the fundamental abstraction? How does the bottom layer work? Can you just tell us?
Sir,
Yeah.
am I understanding you correctly, that what you're actually trying to say is that the complexity of the clustering shouldn't be up to the application? It should be up to the underlying layer, for example, the data store. Then the data store can handle the clustering, and then the application itself doesn't need to be aware of that clustering exists.
That's the claim, yes. I believe that's the claim.
Yes.
So I would be interested to hear how that should work.
So,
This is fine. We'll take this as an input.
yeah.
And we'll see if we can make this work. Because
Okay.
maybe we still need to drill down to the details of clustering. I mean, what we'll do in the short term at least. In the long term, we will try to provide maybe an API or no API so that apps can be built the most easy way possible and still have good performance.
So,
And I'm assuming we are still doing the clustering situation just from a high availability and failover point of view, right? It is not from a scalability point of view, we are trying to do this design. Is it correct?
Scalability is not possible without being cluster aware. I mean, that's what I feel. But again, we have to think about it. I don't know if this not all case, we probably have to look at other examples of it and see if there are systems which solve it in a way where applications are completely cluster unaware and still have good performance.
For that one, I think, for example, you could have multiple front ends and acting on a cluster database, just for example. So in that sense, the front end is not cluster aware, but it's working so that you have high availability because all those information are replicated to the cluster database. So in that sense, it is possible to have high availability without being cluster aware.
That's true, but you're talking about client applications which exist outside the process, the controller process. We're talking about applications which are running.
You mean the plugins installed in the same Karaf.
Yes.
But if we look at it, I think if we try to design it in such a way that we don't have to look at it like it is, because it's in the same Karaf, then, I mean, it's in the same OpenDaylight distribution, then it doesn't have to be that way. That's why we have layers, for example, like the MD layer and whatever.
The layers are there, but they are not
So you be running in 3 different processes and you don't want to be aware of that. That I mean, there is a challenge in that. And
That's
you
not
want to
totally.
overlay.
But
you can do that in many ways that are still application unaware. So you can do it partitioning, right? So you can say, oh, this request comes for this segment of the switch, it goes to this guy. If it goes to this segment, these ports, it goes to this guy. Cool. Each one is not aware that the other guys are doing anything. And then if one of them dies, yeah, you just switch it so that this guy's doing 2 of them instead of 1.
Yeah, something like modular of all the available.
I'm not claiming it's easy. That million lines is really hard. But you guys are all smart.
But
Nobody's on top.
that's actually what we're talking about here. Like when I was talking earlier about OpenFlow, computing the flows for an OpenFlow switch, for example, on whichever node happens to be the master for that OpenFlow switch, you compute the nodes for it. So that's, this isn't some
what's the time?
magical complex thing. It's just a question of partition.
I think we have to
broken
take
down
this
to the
discussion
set
outside.
of
Yeah, I think
things.
we have to take this
But you need to
discussion to
know
that
what
first room,
partition you're working on.
the
You need
ballroom,
to subscribe to the right
yours.
set of data.
But again, the axiom, you gotta start with the set of axioms, right? So my axiom when I had 50 designers who were application designers was, it should take them a day to do something, even though I'm gonna make this multitasking, multi-threaded, multi-site, right? That means I have to hide all that crap, and I have to be clever about how I do it.
So the point is like it will make the life easier for the application developers. Like imagine you have like 50 applications and all of them have to be cluster aware. Each developer will have to have like a similar kind of code dealing with that cluster awareness, and then the possibility of bugs in like 20 of them will be much higher. If all that can be abstracted out and provided as a service, then it will make the app developer life easier. It will make
That's
things
what
faster.
we're proposing, I believe. It's a service essentially.
Probably we didn't hear it.
applications to be cluster aware.
So, I mean,
No, the cluster aware just means you're using the API that is provided.
exactly.
There's an API that says if you use
So
this
what
API,
the app will have to do is just be aware of data persistence. Like if a new copy of the app comes up, it should know that there is some existing data, reads that up, like read existing data. So it will be just aware of data persistence, and that will work for single node systems as well as cluster systems. The app itself
Confusion, like Moiz should correct it. I think currently the application, if an application doesn't talk to the rest of the world, it does something on its own.
Thank you. If you write in Lithium, if you write an application that's just based off of like ANG models and stuff, it doesn't need to know anything about the cluster. It can fail over and things should work in theory, right? So what we are talking about in OpenFlow plugin is a little bit of different scenario. What is happening is OpenFlow has its own ways of dealing with how the resiliency should work. And of course, the OpenDaylight has a raft-based algorithm and a clustering mechanism. It's a question of how to bring them back. It's not about, if you want to talk about performance and things, there is a clustering awareness and all those aspects are there. But I think the discussion is more focused on how the HA of the OpenFlow, how the HA of the ODL need to come together. Is that?
These are 2 totally different things. Firstly, there is the data. The data is, the data store is such that regardless of how you write your application and where you're trying to use the data store from, you don't need to care. You don't need to be aware of that at all. So that is, I think that's clear, right? So now the next thing is, do you want to be aware of where the OpenFlow switch is?
That piece what you're asking for already works.
Yeah, the data. You don't need to be aware of where the data is.
You're talking about data, I'm talking about IO, I'm talking about everything.
Yeah, so now let's talk about RPC. You don't need to be aware of where the service is deployed as well. You can just invoke it. Now we started talking, I think where Rob was going is, I want to be able to compute all the flows and invoke them locally. Now if you want to do that specific thing, how do you do that without being aware of where you are?
There should be somebody should specify the model, right? So one of the things we did is like, we're cheap, simplex. We're a little bit smart, we're a little bit willing to do 1 + 1, active, cool. N + 1 would sure be rocking. Okay, then we do partitioning. But it's a model that we describe independently to the applications. The applications still didn't know any of that crap. And that was our goal. So I'm just saying, have a vision for what your solution success success looks like. And for me, it was always, if my applications ever had to tell me about, or I ever had to tell them about clustering or partitioning, I failed. That was my.
Do you know of any open source solution which actually manages to do this without apps being cluster unaware?
Well, I have to.
Or with Collabs?
I'm embarrassed to say I'm just new to the open source community. I'm used to the closed source.
No, so you're talking about the some closed source solution which does this.
But we can.
I have two open source examples.
Yeah.
If you take Elasticsearch, and
Mhm.
if you take even this one Hazelcast, right? They distribute the data in different nodes, and when the consumer wants the data, they are able to shard it and compose it data from different nodes.
Yeah, we are able to do that as
Yeah, we are able to do that.
Yeah.
That's not.
So we are not talking about data here.
Consuming apps are totally aware how the data is distributed.
Yeah, you can write your apps that way.
I think.
Two different things again, I think. We are not talking about somebody consuming the controller. We're talking about
Well, I
apps
think-
running inside the controller who are part of the process.
You want to access the data across the cluster, you don't have to be
If you want to be, if you want
actually fully aware of it.
smart as the data
I
store
don't know, this is
is, then you have to know the cluster available. If you don't want to be,
So why do you need to know the cluster awareness?
The
you don't need to know.
No, but you just said that.
no. The reason. Okay.
If I want performance, I need to be cluster aware. Explain it.
Evolution of software, like a few years ago, somebody told me that if my app is not thread aware or multi-threaded, then it can't scale, right? And in the last few years, they developed those functional programming, right? Scala and stuff like that. That is, when you write your code, you're not thread aware, right? But it's still in the background. It's thread aware, right? So I'm guessing. That didn't require the applications to be written to be functional programming, right? Like it's still, you could write, if you're writing a new program, yes, we could give the best practices. So OpenDaylight is making the legacy applications which were actually maintaining local state, not even in the data store. I would argue if your application is maintaining local state, like inside itself, which nobody else has access to, there is no way you can make that scale. If you're writing the application for the system, after the system has been designed, you could abstract it so that it doesn't have to be aware of. Which is the case in OpenDaylight and everything. So great point. So what I think that Scott is trying to say is define the way to write an application in a way that it shouldn't be cluster aware.
Yeah, exactly. So, I mean.
No, why do you need to be?
To clarify one thing, we did submit a few million lines of code, I think, into the Linux kernel. We had 10 guys working with our Linux kernel, that's pretty good. But you can use the MMU to keep track of what changes you've made to your local data store and synchronize that too.
I think the
But
fundamental question
our
is,
fundamental thought was thread,
When you guys say application, it's really talking about the extension to the OpenDaylight platform, not the application run outside of,
Yes.
on top of Open.
So in that sense, OpenDaylight platform core. So actually, everything inside OpenDaylight, which is running in process, is itself an application. There is no such thing in the OpenDaylight as a plugin. Even MDSAL is an application of the Gara. OpenFlow plugin is an application of the MDSAL. RESTO is itself an application.
so that being the case, an application inside the controller, apart from data store, if it is going to access any other entities, and if they are already similar to MDSAL, right, they are cluster aware, right? Why does these internal app need to be cluster aware?
See, if you want. Yeah. Go.
I think just to clear the terminology, you talked about Elasticsearch, right?
Yeah.
When you have an external client and you have a cluster of Elasticsearch services running, the client does not need to be aware of where the data is.
Right.
Somehow the data is brought in. The same thing is true of our data store, internal data store as well.
Okay.
So there is no difference there.
Right.
Now the difference is, now what if you had an application within the, see Elasticsearch, you don't host an application in there. You don't have a forwarding rules manager in Elasticsearch. You do have a forwarding rules manager, right? Now, do you want this forwarding rules manager to only program switches which are connected to this controller, or you want this forwarding rules manager to program switches which is ask this from here.
Right, right,
You agree with that?
yeah.
That is why forwarding rules manager needs to know if this entity S1 is connected to this instance of the switch of the controller or to some other instance.
The forwarding rules doesn't need to know.
Doesn't need to.
No.
Actually,
No. Just making an application. It's not a FRM.
yeah,
Just making an application.
That's what they were trying to also point out. There is two different ways how to solve it. The forwarding rules manager needs to be aware where the switches are, or the platform needs to be aware where the RPC is implemented and who will be involved in it. And given that, we could abstract something away from the forwarding rules manager to the platform, and applications are not yet still not cluster aware, but the platform could make that possible.
I think one more. I think just one thing he was trying to say that need versus want, right? You don't need to know that. Even in whatever they are proposing, they are saying you don't need to know that. You can still configure flow on a remote control.
Yeah, I know that.
Without being aware.
Yeah, so even if you you're kind of looking at the small picture and say, I might say virtualization
Just draw
is what
another
we're all about.
controller.
So any more pictures? No, I'm just saying that will be slightly faster than going a slightly longer route. We all know what routing, right?
Yes.
But by doing it so it's not applications aren't aware, you can scale more. So you can have more processors doing slightly less efficient work, but you'll still scale more.
Yeah.
Well,
We can do that. We can do that.
There's actually
The-
only one controller that can talk to a given switch. You can't scale better by having the computation of flow rules happen on a different controller. That is always going to be stream close.
I think we have till 11:45, I believe. Yeah, the two parts. We have till 11:45.
We just blended it, or we have a break?
Yeah, no, we have a break from 10:30, I believe.
You would want to take a break and come back, or continue?
We've been in our, I think we need a break.
Yeah. Okay, let's take a break, guys. Let's take a break and come back in 5-10 minutes.